Good morning, children. The topic for today is magnetic properties of solids. The microscopic observable magnetic properties of any material are due to the magnetic moments associated with individual electron. Each electron has magnetic moment which originates from two sources: the orbital motion around the nucleus of the electron and the spin of electron in its own axis. The fundamental magnetic moment is the Bohr magneton, mu b. The value for mu b is 9.27 times 10 raised to power minus 24 ampere square meter. For each electron in an atom, so there are two magnetic moments. The spin magnetic moment may be plus minus mu b depending upon whether the electron is spinning clockwise or anti-clockwise, and its orbital magnetic moment which will be ml mu b. Now, the materials of the magnetic properties of solids are also related to their electronic structure, and depending upon their response to magnetic field, these materials may be divided into the following types. Diamagnetic materials. The substances which are weakly repelled to the magnetic field are known as diamagnetic substances. For example, sodium chloride, water, benzene. These are diamagnetic substances. Their diamagnetic nature is attributed to the presence of paired electrons in these materials. All the electrons are paired up. The paramagnetic substances, the substances which have permanent magnetic dipoles and are attracted by the magnetic field, are known as paramagnetic substances. Example: cupric ions, ferric ions, chromium ions, dioxygen, titanium monoxide, dititanium trioxide, and cupric oxide. These are paramagnetic substances. The paramagnetic substances lose magnetism in absence of magnetic field. The third category is ferromagnetic substances. The substances which are strongly attracted by the magnetic field and show permanent magnetism even in the absence of magnetic field are called ferromagnetic substances. A ferromagnetic substance has greater number of unpaired electrons, and examples are cobalt, nickel, gadolinium, and chromium dioxide. Chromium dioxide is the oxide used to make magnetic tapes for use in cassette recorders. In solid state, the metal ions of ferromagnetic substances are grouped into domains. Each domain acts as a tiny magnet. Now, depending upon otherwise, in normal conditions, the domains are randomly oriented and their magnetic moments get cancelled. When these ferromagnetic substances are placed in a magnetic field, then their domains get aligned. Depending upon the alignment of magnetic moments of domains in ferromagnetic substances, these can be further classified into three categories. If all the domains are spontaneously aligned, when there is spontaneous alignment of magnetic domains in the same direction, then the substance is called a ferromagnetic substance and the phenomena is called ferromagnetism. A ferromagnetic substance is strongly attracted by magnetic field. If the domains are oriented in such a way that they mutually cancel each other and the net magnetic moment is zero, then we get anti-ferromagnetic substance. So manganese oxide is anti-ferromagnetic even in the presence of unpaired electrons. The domains are oriented in opposite directions but unequally, so that there is some net magnetic moment. Then these substances are called ferromagnetic substances. These are weakly attracted by magnetic field. So the difference between ferromagnetic and ferromagnetic substances, these are strongly attracted, these are weakly attracted. Then these do not lose their magnetism on heating. These lose their magnetism on heating. So these are the different kind of magnetic substances.